Hello and welcome to Introduction to Physics. My name is Paul Eric, and today we want to go over Lab 4.2a, which is on electrostatics. So when you open up the document, this is what you ought to see in Microsoft Excel, and we're going to learn about what the electric force is, what the electric field is, and then also some electrical properties of materials. So we're going to start off with part 1, and so if you will go on down to there, we're going to look at the electric force. And so the electric force is going to be given by F for force, and then it is the electrical force, and then it's going to be equal to a constant K, which we don't care about. So this constant is the electrical constant, and it determines the strength of electricity. So we don't even care about that. But you should notice that it also depends on Q1 and Q2. So this is going to be any two electrical charges, and then they're going to be separated by a distance r, and then we need to square it. So this is going to be called Coulomb's law. So we're going to investigate this law by using a PhET simulation. So you need to go to the internet and then go to Google and then type in PhET Coulomb's law. And so when you do that, so let me go to it here for you. Let me go to it for you. All right, there you go. So when you first go there, this is what you're going to see. And then we're going to click on the Go button here. And there it is. And then we're not going to do the atomic scale one, so we're going to do the macro scale. So click on that one. Okay, and then this is the picture that you see in your lab. And then what you're going to notice is that if you grab these electrical charges Q1 and Q2, you can move them back and forth. And then you can also move the ruler back and forth if you want to. And then you can also change the charges. So this is the charge on this ball here is given down here. So you can make that larger. And notice it could be a positive number, or you can, if you go to the other direction with it, you see that the numbers become negative. So I think I'm going to leave this one as a positive number over here. And then you can also do the same thing to charge number 2. So charge number 2 can be a positive number, or it can be a negative number. Okay, now what I want you to do though is I want you to lower this charge until it's a relatively small number there. And same thing for this. So we're going to set these two so that they're about equal to each other. Okay, now up here you see that there is a force on charge number 2 caused by charge number 1, and then you got the force on charge number 1 caused by charge number 2. So what do you notice about these two forces? They're the same number. Okay, now later we're going to find out that this is one of Newton's laws of motion. So this is the third law of motion, which says that for every action there's an equal and opposite reaction. So if one ball is pulling on the other ball, then the other ball is pulling on the first ball. So what I want you to do is just to ignore one of these numbers. So since they're both the same number, you can just basically ignore one of these numbers and just look at the other number there. So this is the force of electricity caused by these two charges, charge 1 and then charge number 2. Okay, so let me put this away for a moment, and then let's go back to the lab. Okay, and then let's go down a little bit here. Now, Anything that you put into the lab, I want you to make it in red. And the way that you do it is up here. You see where it has the letter in red. If you click on that, then anything that you write will be in red. If you highlight anything, so let's say that I highlight this statement, and then I click on this button, it will turn it into red. Okay, and then if I want to change it back into regular black, then I can go back to automatic. So anything that you put into the lab, make sure and do it in red so that I can see what you wrote as compared to what I wrote. Okay, so I'm going to let you do and answer question number 1, and same thing for question number 2. Okay, so take a moment and do that. So what you're doing is you are changing the charge on one of the masses, and you're looking at what happens to the force. And the goal is to try to figure out if does the force of electricity, is it proportional to charge 1, or is it proportional to 1 over charge 1? So this one is called a directly proportional equation. This one here is a inversely proportional one. So what's the difference between the two? Okay, so on this one, you notice that the Q is in the numerator of the formula. So if this number gets bigger, then what will happen is this number will get bigger. So if let's say that I double Q1. If I double Q1, then you should know from algebra that if I multiply one side of an equation by 2, I have to multiply the other side of the equation by 2. So that when you have a directly proportional equation, if this thing gets bigger, then this thing over here has to get bigger. But now let's take a look at the second one here. So you should know that 1 divided by 1 is 1. Okay, but what's 1 divided by 2? Okay, so that's going to be 0.5. So you see, if this number here gets bigger, then what comes out of the formula gets smaller. So that's the difference between a inversely proportional and a directly proportional. So what you have to figure out is that if you increase the charge, what's happening to the F? And so therefore, should the Q be going on the top part of a formula, or should it be going on the bottom part of a formula? Okay, and don't look at this thing up here, okay, because that's giving you the answer. Okay, now it then says now increase the charge on charge number 2, and then what happens to the force? So you did it for charge 1, okay, and then what about charge number 2? And so then based on that, where does charge 2 go? So does charge number 2, is it going to go on the bottom, or is it going to go on the top? Okay, and so now we're down to part 4 there. And so go ahead and answer that question. All right, so now you should know where the Q's go. So now we want to know, what about the distance? So this time you're not going to do anything to the charges. So keep the charges the same. But this time what we're going to be doing is changing the distance between the two balls. And you can grab the ball and move it anywhere that you want on there, so you can change the R values. And so we've got three possibilities here. Again, we're going to try to come up with a formula that relates the force of electricity to the distance. So the first one says that the force of electricity is proportional to the distance. So this one would be saying that the force is proportional to R. So we're going to use the letter R to represent distance. The second one is saying, is the force proportional to 1 over the distance? And then the third one says, is it proportional to 1 over the distance squared? All right, now if you have looked at your formula up here, you know what the answer is, but I want you to try to reason it out. So why is this one not correct? So this one would say if you increase the R, it should increase the F. And so that's not true. Okay, so then the next possibility is that it's 1 over R. Now that one's better because that one's saying if you increase the R, it decreases the force. So now our question is, how do we know whether it's 1 over R or is it 1 over R squared? So there's a way of telling. So what you're going to do is set the R to a certain distance. Write down on a piece of paper what is the force. Okay, now double the distance. So I want you to double the distance, and then on a piece of paper write down the force. Okay, now you're going to compare those two forces, because if this is the answer up here, then if you double the R, so that's a 2, then the force would be 1/2. So compare the two numbers that you wrote down on your piece of paper. Now if it's a 1 over R squared, then put the 2 in there. 2 squared is 4. So 1 divided by 4. So look at your two numbers that you wrote down and see if one of those forces, the second force, is 1/4 the original force. And see if that's true. So that's going to tell you which of these two is the correct answer. Okay, so we're going to take a break, and when we come back, we are now going to do part 2.